Hello, this is Wafer Agent. People often think of semiconductor factories as places full of advanced machines. But in my view, the biggest enemy in a semiconductor fab is surprisingly small, a single dust particle. Today, we'll explore what particle is and why flatness matters so much in wafer manufacturing. A particle is any microscopic foreign material present on the wafer surface. As circuit line widths shrink to just a few nanometers, even a particle that is invisible to the naked eye can be larger than the circuit itself. When a particle lands on a circuit, it can cause a short circuit, a pattern defect, or complete yield loss. Wafer companies manage particles across every process step: slicing, grinding, polishing, cleaning, and packaging to prevent new particles from forming at any stage. Because what customers ultimately want is not just a wafer. They want high yield. Particle measurement is generally performed using laser light scattering. A laser beam scans the wafer surface. When it hits a particle, the light scatters. Sensors detect this scattered light, and the system generates a particle map showing the location, count, and size of each defect. Laser-based surface inspection systems are widely used in the industry for this purpose. Specific equipment specifications vary by manufacturer. The result is a wafer map that allows engineers to evaluate whether the wafer meets the required particle specification for each customer. Flatness refers to how flat the wafer surface is. But in semiconductor manufacturing, flatness is not just about being flat overall. Three types are managed: global flatness, which covers the entire wafer bow; site flatness, which covers the flatness within each chip area; and edge flatness, which covers the wafer edge region. Why does this matter so much? Lithography equipment can only print circuits accurately at a precise focal point. If the wafer is even slightly warped, the focus shifts, and the circuit pattern becomes blurred or misaligned. As EUV lithography advances, flatness requirements are becoming even more stringent every year. Flatness is generally measured using capacitance or optical interferometry methods. In summary, particle is a microscopic contaminant that can destroy circuit patterns and reduce chip yield. It is measured using laser light scattering techniques. Flatness determines whether lithography can focus accurately. Global, site, and edge flatness are all managed, and requirements grow stricter as nodes shrink. Both parameters are invisible to the naked eye, yet they directly determine whether a chip lives or dies. In the next episode, we'll explore nanotopography and metal contamination, two more hidden enemies of wafer quality. Thank you.